Section 4.2 is what we're about to cover. Now this is the verification part of identities. So this is the important part. Not that the other wasn't, but this is very important. Verifying identities. Okay, so for instance, all the directions will just say verify the identity. Okay, so in other words, it's your goal to prove that a problem like this equals this. So it's your goal to prove that something like that equals the other side. Now, a good rule of thumb is to start with the more complicated side of the expression and try to transform it into the simpler side. If that doesn't work, if you get stuck on one side, then forget it. Go to the other side and try to make it look like the more complicated side. It doesn't matter what side you start on. It's just a matter of you being able to prove one side equals the other. So every step you take, you need to keep in mind of what you're trying to get on the other side of the equation. Okay? So as I do work this problem, I need to remember that I'm trying to get a negative cosecant x. So one rule that I know automatically, and I'm going to give you this, but you need to know it in terms of being able to solve problems for homework. I know for a fact that I have identities for negatives, and this is one of my identities for the negatives. So automatically, in my mind, I can relate that identity here to this right here. And so I'm going to start with the left-hand side because it's more complicated. And I'm going to rewrite cosecant. Okay? Cosecant is the same thing as 1 over sine. Okay? And now, because I know this identity, I can rewrite the sine of negative x as 1 over the negative sine of x. And because I know my reciprocal identities, I know 1 over sine is cosecant x. So this is negative cosecant x. Check. I have verified the problem. See how easy that was? Now, this is one of the easiest kinds. So I'm starting you off easy. So don't get your hopes up that they're all going to be this level. But they're going to get more difficult as we go along. But this is the goal. Okay, I had in mind the whole time what I was trying to get. And your goal is to try to relate some kind of identity in there. Okay, so let's step it up a notch. Okay, and let's do this one. Let's do tangent x sine x plus cosine x equals secant x. Now the reason I say go from complicated to simple is because it'd be hard for me to think of a way to take secant x into the one on the left hand side. So it might be quite possible to take the left hand side and transform it into something on the right hand side. Okay, so the first thing I know in my mind, secant x. Secant x is a form of cosine, right? It's 1 over cosine to be exact. So secant x is a form of cosine. So I should be trying to get 1 over cosine somewhere in this problem on the left-hand side. Because I got to get 1 over cosine somehow because it's secant. Well, that tangent x is throwing a kink in my giddy up here. Because think about it. I'm trying to get it in terms of 1 over cosine. So tangent it's not in the right form. So I need to take tangent and write it in terms of sine and cosine. That way I can be able to manipulate this and have everything in terms of, the goal is to have everything in terms of cosine, so I can write it in terms of secant. Okay, so step 1. Done. Alright, so step 2. What we need to do here is I realize that sine x times sine x is sine squared x. Now, the first thing I notice is secant x, remember, is 1 over cosine. Well, I already have cosine on the bottom here. So my goal is to combine these two and have cosine on the top. Well, let's go for that. Let's try to, we already have cosine on the bottom here, so let's get a common denominator. A common denominator of cosine x. Well, we already have the common denominator here. Now, when we get ready to do the common denominator here, it's still going to be cosine x, but we have to multiply the top times cosine x. So cosine, to get the common denominator, so cosine x times cosine x is going to be cosine squared. It's going to be cosine squared x. Now look what I did there, folks. What do I have on top? What do I have on bottom? Well, I have the desired, I have what I want. I'm trying to get cosine x on the bottom. Check. Do I have 1 on top? Well, if you know your Pythagorean identities, yes you do. Because remember, sine squared x plus cosine squared x equals 1. So really, I do have sine over cosine. And we know sine over 1 over cosine, excuse me, I really do have 1 over cosine. And 1 over cosine is the same thing as secant. Check, I have verified the identity. Okay? So, you can see this is going to take practice again. I could only select, if I could, I know y'all would have hated me for this, if I could have selected 60, I would have selected 60 for you to work for homework. I just think it's that important for you to practice. I selected as many as I could, so don't wait till the last minute to do these. But what you're going to need to do is be prepared to show this work on exams so that you can get partial credit in case you miss something. But what you're going to need to do is practice some of the ones from the section of the book. Okay, you're going to need to get as much practice in on this as you can. Alright, so, well, let's kick it up one more level. Okay, so we have cotangent squared x minus 1 over 1 plus cotangent squared x equals 1 minus 2 sine squared x. Alright, the right side's obviously easier, so I'm going to start with the left. So obviously I'm going to have to take cotangent at some point, and I'm going to have to get it in terms of sine. Okay, I'm going to have to get it in terms of sine. Well, here's what I know. I know sine squared x plus cosine squared x equals 1. Okay, that's relating sine and cosine. And I can very easily change cotangent back to sine and cosine. Keep that in mind. I know also, at the same time, the Pythagorean identities that are very rarely used are going to be tangent squared x plus 1 equals secant squared x. And I also know that 1 plus cotangent squared equals cosecant squared. Equals cosecant squared x. Well, let's do it the hard way first, and then we'll try to manipulate it in another fashion. Okay? So, I'll show you two separate ways to do this same problem. So the first thing that most people do, okay, most people will rewrite cotangent in terms of sine and cosine. So cotangent squared is cosine squared over sine squared. Same thing down here. Well, now if you notice, we have the same common denominator. If we tried to find a common denominator here, we have the same one for the top as we do the bottom. So we can multiply through again to get rid of our complex fractions. So my common denominator would be sine squared x. So I'm going to multiply through top and bottom by sine squared x. Okay, so sine squared times cosine squared over sine squared. The sine squareds cancel, and that's going to leave me with cosine squared x. And then sine squared times 1 is sine squared. All over sine squared times 1 is sine squared. And sine squared times cosine squared over sine squared. The sine squareds will cancel, leaving me with cosine squared. Now, you can easily see that the bottom is going to equal 1. That's your Pythagorean identity. So really what I have is cosine squared x minus sine squared x. Cosine squared x minus sine squared x. Okay, all over 1. So just cosine squared x minus sine squared, because this right here equals 1. Now, at this point, you've got to take a look at your right-hand side. What am I trying to convert it to? Well, I'm trying to convert it to sine squared. So notice I have cosine squared. I know sine squared plus cosine squared equals 1. Well, if I take this, and if you think about it, think carefully, we're trying to get it in terms of sine squared. So that means I need to get rid of my cosine squared. So I need to figure out what cosine squared equals. Well, if I solve this Pythagorean identity for cosine squared, I get 1 minus sine squared. I get 1 minus sine squared. Alright, so I can take this and substitute it in for cosine squared, and that's giving us everything in terms of sine squared like the right hand side wants. So that's 1 minus sine squared minus sine squared x equals 1 minus 2 sine squared x. Alright, so check, we have our answer. So you can see this one's a little more work, okay? Now, lots of substitutions and identities and cancel out and things like that. But now this is the most common way people do that, because people get on tests and you get panicky about things. And what I see the most on tests is, instead of using identities, you've got tons of identities by the end of this chapter that you're going to have. You're probably going to have 25 or 30 of them, okay? And instead of using a identity to substitute in and make this a shorter process, people typically get antsy and they want to change everything back to cosine and sine and do it that way, just like we've done here, and that's perfectly fine. there are just more efficient ways that you could solve this problem. Um, so, for instance, if I took the same problem and I'm going to verify the left-hand side of it again. Now remember, I have an identity. Okay, another Pythagorean identity. Sometimes people get hung up with sine squared x plus cosine squared x equals 1. There are other Pythagorean identities. And one key one is 1 plus cotangent squared equals cosecant squared. So I know automatically that this down here on the bottom is cosecant squared x. I can solve for cotangent squared x, which is cosecant squared x minus 1, and I can make that substitution on top. I substituted in for this. Okay? Now notice what happens here. We have cosecant squared x minus 2 all over cosecant squared. So if we were to break this apart, this would be cosecant squared x over cosecant squared x minus 2 over cosecant squared x. Well, cosecant squared over cosecant squared gives me 1. And this is the same thing as 2 times 1 over cosecant squared x. Well, think of your reciprocal identities in reverse. What cosecant squared is 1 cosecant squared, cosecant x is 1 over sine. Well, in the same instance, sine can be the reciprocal of cosecant, if you remember. Okay, sine is also the reciprocal of cosecant. So really, I have an identity here. 1 over cosecant squared is the same thing as sine squared. So this is really 2 sine squared x. Okay, so notice we got the same answer. We verified it. I think this is a little easier process. Okay, it's just a matter of you being able to apply the identities. So remember, there are many ways to solve these problems. Okay, so this is the first video. We'll come back and we have 2 more identities that I want to verify. They're 2 of the ones that are a little more difficult. Okay, so we'll show you those on a separate video.